Hello, everyone. Welcome back. I hope everyone had a good Thanksgiving. Um, I wanted to kind of talk about where we are in the material and what's left for the semester. So the tentative calendar is a little bit off since we didn't have class that one day and we missed 4.3. Actually, this week, instead of 4.4 and 4.5, we're going to be going over 4.3 and 4.4. And then on Monday of the last week of classes, we'll be going over 4.5. And then on Wednesday of next week, so not this Wednesday, but next Wednesday, we have our final quiz that needs to be taken in class. It needs to be taken in class. We mentioned that at the very beginning. I know it's been a while, but we've been talking about it. So that one needs to be taken in class. It is just like any other quiz. It's worth the same amount of points. It's about the same, roughly the same number of questions, but it's cumulative. And I believe it's multiple choice, unless I'm mistaken. It's a departmental thing. That's the reason why it has to be in person. It has to be in a proctored environment, like specifically with me. So that is the environment that we're going into. So obviously you want to study up for it, but everything, but just know that it's not make or break. It is not the same. It does not have the same total as, say, an exam. We've had like 20 quizzes at this point, or 18 of them. I can't remember off the top of my head. So like just adding one on top of that. So it's not a big deal. Obviously we want to do well, right? Want to do great, but it is not meant to be a situation where you're punished just for like it's not a regular final exam or anything like that. Okay. It says that the exam opens up on Monday and is due Friday, but since we won't be finishing the material until Monday afternoon, I'm probably going to extend the due date a little bit, maybe until Sunday. Maybe I think Sunday is when I'm going to cut it off at. I just realized that today. But it'll cover all material from 4.2 to 4.5, and just like normally, you have 3 attempts at it. The final quiz, there's only 1 attempt because it's in person during that time period. Then for us, week 16, no final, nothing. Once you've taken that final quiz, you're free to leave and you're done with Math 120. So we're nearly done. Does anybody have any questions on that setup? I'll be sending out an email reminder later today or tomorrow, and then probably tomorrow, and then another email on next week to take the final quiz in person, but the exam is still taken online like our other ones, like normal.
Last year.
Okay. Then so with that in mind, yeah, as soon as we finish on Wednesday of next week, you are free of your obligations for Math 120. So next Wednesday, that is next Wednesday, not this Wednesday. And then to give you kind of a breakdown of what's going to happen, I'll probably mention it again at some point, but once the exam is in and all the grades are calculated, I'll be making a new column in Canvas. Canvas is not where your grades are recorded. My CSN is where your grades are officially recorded. So they are just tentative until I enter them into my CSN. So what's going to happen is sometime during finals week, I will be sending out an email to you guys that I've created a new column in Canvas that says your final course letter grade. That'll be your that'll be the grade that I'm going to enter into my CSN, as long as everything goes according to plan. Upon receiving that email, you have about 24 to 48 hours to email me with any discrepancies, any issues that you see. So if there's a problem with like I meant to give you points back and I never gave them back to you or something like that, that's when those things need to happen. So that if there are any problems, you let me know. If I don't hear from anybody, then I will just go ahead after those 48 hours and upload them to my CSN. It's very important to find those discrepancies before I do that, because if there's an error after the fact, then it becomes a very, very large nightmare for us to deal with, where we have to kind of make a grade change request form. It's a little nasty situation. So please check those things, and then they'll be entered into my CSN roughly about 24 to 48 hours after creating that column in Canvas, okay? The other thing for the end of the semester is that you've probably started to receive them. Have you started to receive the evaluation emails? Okay. A couple things about those to know about. First off, it's going to start getting real aggressive about it. Basically, what's going to start to happen if you haven't already done them is you'll click on a link, you'll like go to a new course or something like that. You like go to your course webpage, your Canvas webpage, Canvas homepage, that is. And it'll say you need to do your evaluations. Click do it later. You click on a new link, it says you need to do your evaluations. Click do it later. You click on a new link, you need to do your evaluations. I just want you guys to know I have no control over that. That is not a feature that I want. I would rather them just send you an email reminder like once a week until the end of the semester. That seemed like a good enough reminder, but no, they want to be extra hard about it. Yeah. Just no, I'm sorry, that has nothing to do with me. What I will tell you about the evaluation process is that you put in those evaluations. I do not see them until the semester is already over, grades are entered. I see it basically in January, usually is when I get the email that they've been finished. So, and then in addition to that, it is completely anonymous when I get those things. So for anything where you plugged in your like your rating from like 1 to 5 or whatever, those things are all just compiled and given to me in a chart. So there's no way to know who said what. And then any of the comments that you list to me, those just get put in as bullet points. It just says bullet point 1, and it says what the person says. It doesn't tell me who said it. It doesn't say who submitted it or anything like that. It just says that this comment. So there's no way for me to trace it back to you anyways, even if I could. There's nothing in there that allows me to figure out who said what. Say in an English class, so I can't be like, oh yeah, that's totally something that you would write and then mark you down. And since I don't get it until way after the semester's over, it's there's no way that it could be used for retaliation. I hope by now you know that that's not who I am or what I would do, but in case you were worried about another teacher or anything like that, there's nothing they can do with those evaluations. It's complete.
Can't come find you.
They can't come find you. Exactly. So just know that it's completely anonymous. My request is for you to please finish those, especially like if you can do them now, so when the crunch time isn't as heavy. But I don't presume to know that you get I don't presume to know that everything that's going on in your life, and I'm assuming there's plenty of other things that you have to take care of. So if you don't get to those evaluations, I totally understand. It's not a problem for me. But I really hope that you do, because those things are the only way that our school gets better and our teachers get better is by you giving us your honest criticisms and us learning from them. Some teachers don't look at them. I would hope that everyone does, but I'm not jaded by white knighthood. But I will tell you that I look at these every single time I get them every semester. Once the semester's over, I like looking at them and figuring out what people like and what they disliked. So if you can give me those honest criticisms, I would greatly appreciate it. As much as I love and try to be detailed if you can. So like, as much as I love the comments of like, Phil, you rocked, or Phil, you sucked ass. Doesn't really tell me much, right? Like, what did I do that rocked? What did I do that sucked said ass? You know what I'm talking about? Like, what is it about my teaching style that wasn't good or was good? What was it about, like not just my teaching style, but also the course structure, the course breakdown, any of those things, any problems that you had with it, or any things that you wanted to highlight and say that were good. I really take these things to heart and trying to improve my courses where I can. For example, one of my students said at one point, I was giving a review before my quizzes as a TA. Like, so we would do a little like 15-minute review and then we take the quiz. And he said, I actually really don't like that because it makes it so that I don't find the need to study. So like, I just assume that I'm going to get to know what I need to know before the quiz and I don't study. Interesting comment. He was the only one who made that comment to me. It could be a he, could be a she. I don't remember. But they were the one that made that comment to me. And it was an interesting thought of like, maybe I shouldn't necessarily give a little review before the quiz because that won't encourage people to study. I thought about that comment for a long time. It's been 10 years. And I still think about that one student's comment. Exactly. So like they're like, I know I can't please everybody. And so like there's gonna be some people who say I go too fast and some people who say I go too slow. You can't please everybody. But if you can give me those honest criticisms, if you have time, I'd greatly appreciate them. What did you like? What did you dislike? Was there anything about the core, like not just about my teaching style, but about the course structure? Any ways that it could be improved upon? The navigation of the course website, was it fine? All that stuff. Those are things I'm looking for. So yeah, if you can go through those things, awesome. But if you don't get to it, I totally understand. It's not a problem for you to not do it. It just know that like it will do that annoying thing where it keeps asking you to do it every single time you open Canvas. I wish I could turn that off. I've asked our IT department, they said no. Whether they're lying to me or not, that's a different question. So probably. Might even try and bring that up to faculty senate at some point. So like, can we get rid of that requirement? Can we just make it so it's an email reminder every week? I even take every day just an email reminder. Like that would be better than just having it so that I have to keep like whenever I want to click something, do it. But anyways, I'm getting sidetracked. Does anybody have any questions on the last kind of 2 weeks of the class? All right. Then we will pick up where we left off. So I'm going to stop sharing on this computer and start sharing on this computer. All right. Oh, this is my other classes one. This is us. I think we were right here. Okay. So we set off last time to talk about the different types of terminology of probability, specifically that the results of an experiment are called the outcomes. The sample space is the collection of all the possible outcomes. Theoretical probability is basically just probability. It's what should happen based purely upon math, where empirical probability is probability that is done based on repeating an event enough times to figure out a possibility. A key example that I can think of is, for example, football and third down conversions. Like if you watch football, by the end of the fourth quarter, they'll say like the Seahawks have been 7 of 9 on their last third down conversions. And so you can look at that and say, okay, there's about a 77% chance that they make it on this one. It's not accurate, right? It's not 100% true, but it is a good gauge of whether or not it will happen. So I want to do an example of probability terminology. Kind of set everything up, and then we'll actually start computing probability. So the experiment is flipping a coin 3 times. So we're flipping a coin 3 times. That's the experiment. So then the sample space. Oh, well, let's actually do the, let's do the outcome first. An outcome is any possible combination. Like heads, tails, heads. That is an outcome. That is one possible outcome. There's heads, 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 tails, heads, whatever it may be. But that's an outcome. The sample space is all the different possibilities. So if you flip a coin 3 times by the fundamental counting principle, you just multiply the outcomes of each event. two options, two outcomes for the first event, two outcomes for the second event, two options for the third event. 2 times 2 times 2 is 8. So there's 8 situations, but that's going to be heads, 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 tails, heads, tails, heads, heads, tails, tails. Those are all the situations that would occur if you first flip the heads. And there's 4 other ones. There is tails, 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 heads, tails, heads, tails, and tails, heads, heads. That is the sample space. It's the list of all the different outcomes. This wasn't described here, but this is an important one, is an event. An event is, write that better, is a descriptor of a set of one or more outcomes. And I want to give you an example of that because that's really, really weird when you first see it. An event is a descriptor of something happening. So as an event, as an example, here's the event. Here's the corresponding outcomes. So the event would be something like flipping heads twice. Flipping a head twice. That is an example event. Or you could say flipping tails exactly once, or flipping tails at least twice. Or flipping a heads and then 2 tails, something like that. Those are all events. And just to be clear about the verbiage, this is implying exactly 2 times. If it said flipping heads at least twice, then you could also include the chance where you flip a heads, heads, heads. Does that make sense? Yeah. So we need to be careful about the verbiage. If it says flipping heads twice, it means only 2 times. If it says at least twice, that would mean either flipping it 2 times or flipping it 3 times. So the corresponding outcomes here would be heads, heads, tails, heads, tails, heads. Let's see here. And then tails, heads, heads. Those are the only ones, right? Those are the only ones that have 2 heads. Yep. So there's 3 outcomes corresponding to this event. Does that make sense? What an event is then? So then the probability formula. Probability formula says the probability of an event which is typically denoted P parentheses E, like that, which might look a little strange to us. This is a notation that's used later on in mathematics for functions. This is red P of E, and then meaning the probability of the event E. Is equal to the number of successes divided by the total number of outcomes. The number of successes, meaning the number of ways that the event could occur, divided by the total number of possible events, or possible number of outcomes. The number of successful outcomes divided by the total number of outcomes. So as an example, determine the probabilities below from flipping a coin 3 times. Part A is going to be the probability of flip heads at least once. B is going to be flip heads exactly once. And C is going to be never flip heads. All right. So when you're writing the probability, usually you just try to jot something down that you know what it means, so that when you're looking back at your notes, you know what you were talking about. Don't just write the fraction, just try and write some things. So I'm gonna copy this so we have it for reference. But you don't need to copy it. So for part A, the probability of at least one heads, at least one H. Now you could write H greater than or equal to 1 or something like that. Like however you want to do it is fine. Just as long as you know what it means. But it should make sense. So at least one heads. So looking at these options, that's 1 where you get at least one heads. You get 3 heads, but that's at least 1, 2, 3, 4, 5, 6, 7. All of those are situations where you flip at least one heads. So that's 7 successes over 8 total outcomes. Probability of 1 heads. So exactly 1 heads. P of 1H or 1 heads, so however you want to write it. Let's see here from the first set. This is exactly 1 heads. That's 1. That's another. That's another. So there's 3 situations where you'd flip 1 heads. So that's 3 successes over 8 total outcomes. Last but not least, the probability of no heads. Probability no H. Looking at this, there's only 1 situation that has 0 heads, and that's the tails, tails, tails. So that's a 1 in 8 probability. Any questions on that? Okay. Thanks. Next example. A coin is flipped and a D6 is rolled. For anybody who's not familiar, D6 meaning a 6-sided die. So a D blank is a blank sided die. So a D20 would be 20-sided die, a D4, 4-sided dice. So a 4-sided die and so on and so forth. But you know the D6. Don't have to know, like, if you play Magic, you'll know what a D20 is. So as long as you play some game that involves dice, you know what a D6 is. So it's just a 6-sided dice. So part A is going to be find the sample space. Part B is finding the probability of a tails and an even. And part C is the probability of a tails and 7. Bless you. So the sample space is the collection of all the outcomes. And you can abbreviate it however you want. So in terms of how many options there should be, we can kind of figure that out right off the bat, right? There's 2 outcomes that can happen from flipping a coin, and there's 6 outcomes from rolling a D6. So 2 times 6, that's 12. So there should be 12 entries here, but we can just list them. So you could roll a heads and a 1, heads and a 2, heads and a 3, heads and a 4, heads and a 5, heads and a 6. You could roll a tails and a 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, and then tails and a 6. Those are all the possible outcomes, and that is therefore the sample space with 12 total outcomes. Part B, probability of tails and even, T and E. Or you can write tails and even, it doesn't matter. So all the first 6 are out. Tails and even, that's going to be tails and 2, tails and 4, and tails and 6. That is 3 of the 12 events. Okay. Because there's 3 different possibilities to getting even. So you're flipping at tails. So none of these are options. None of these first 6 work. And then there's a tails and a 2, a tails and a 4, and a tails and a 6. Those are the only options that work. Now, one might be able to look at this and say, well, Phil, you could reduce that fraction, right? 3 and 12 have a common factor of 3. You could rewrite that as 1/4. Which I say nay. I mean, that is true, yes, but writing it as 3/12 gives us more information about the problem itself. So I don't want you to reduce your fractions here. Like if a problem is ever malfunctioning and marking you wrong for not reducing your fraction, let me know and I will fix it for you. This tells us that there were 12 total possibilities, and in 3 of those situations. Whereas if you write it as 1/4, that means that there's only 1 place where it would work and 4 places where 4 places total, which isn't accurate. There were 12 total options. So it's better to write these ones unsimplified. This is like the one time where we don't simplify our fractions. So is that cool? Next one, part C. Probability of a tails and a 7. What's the probability of that occurring? Where you flip a tails and you roll a 7. 0. Exactly right. 0 out of 12 or just 0. That's the only situation where you will quote unquote reduce your answer. 0 divided by 12 is 0. There is no way for us to roll a 7. can only roll a 1 through a 6. That is the issue. So it is. This brings up a good little side note. Important probability. Important probability properties. There's just 3 of them. The probability of an impossible event equals 0. The probability of an impossible event is 0. If an event cannot happen, like rolling a 7 with the 6-sided dice, the probability is 0. 2, the probability of a guaranteed event is equal to 1. A guaranteed event means that in every circumstance, in every outcome, it will occur. So you have every outcome divided by every outcome, you get a 1. And you can think of that as a percentage as well. 3/12 as a percentage is 25%. So there's a 25% in the previous example where you roll a tails and it's also an even number. Or you flip a tails and you roll an even number. And then last but not least, so there's an impossible event with 0 and a guaranteed event is 1. And as a consequence of that, all probabilities are between 0 and 1. If you've noticed, all of our fractions have been what they call proper fractions, meaning that it's a number less than 1. So it's like 3/8 or 7/8. It's always that the numerator is smaller than the denominator. So all probabilities are numbers between 0 and 1 because you can think of them as a percentage as well. And you can't have something happening more than 100% of the time. That'd be impossible. We like to say it in lingo and in typical things, but not actually not actually in real math. It's there a probability that it's more than 1 or less than 0. So now we got to talk about a couple things. I'm going to create a chart for you. The dice and cards. The 2 most common things, especially with us living in Vegas. So I'm going to make a 7x7 grid. I don't know why I made it like that. Whatever. And then let's check this. Eraser. All right. And I should have said sums of 2 dice. So I'm giving you this chart. I'm making you write this down in your notes so that you can look back at it when you're doing your homework and your quiz and stuff. Because when it comes to this thing, there are 36 different possibilities, right? Because you have 6 outcomes for the first dice roll and 6 outcomes for the second dice roll. So there's 36 different options. And if it asks you to find the sum, the situations where the sum is even, trying to get all of those right in your head can be a little daunting. So I wanted to write them all down here. So sum of a 1 and 1 is a 2, then 3, 4, 5, 6, 7, and then 3, 4, 5, 6, 7, 8, and then 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, and 12. You could also make a chart for all the different possible combinations of like, so 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 in terms of your dice rolls, but that's your prerogative. If you want to do that, you can. But this should suffice. So that's for the dice rolling. Let you draw that. That's a lot to draw, so I'll let you finish up. All right. 2 dice are rolled. 2 d6s are rolled. Find part A is going to be the probability both are even. Part B is going to be the probability that the sum is 7. And part C is going to be the probability that the sum is even. And we'll just compute them right off the bat here. So problem A is saying that both numbers are even numbers. So there's a lot of ways you can figure it out. There's no one right answer. What I'm thinking is, okay, so for my first dice roll, in order for it to be even, right? In order for both of them to be even, my first roll has to be even and my second roll has to be even. For my first roll, that would mean I have to either roll a 2, a 4, or a 6, right? And for each one of those options, my second roll could either be a 2, a 4, or a 6. So that's going to be 9 total options. But you can do it in your head as well. 2 and a 2, 2 and a 4, 2 and a 6, 4 and a 2, 4 and a 4, 4 and a 6, 6 and a 2, 6 and a 4, 6 and a 6. That's 9 total. However you want to do it, though, is fine. A 9 out of 36 chance. Now, as a fun little concept, if I was to roll these in 2 successions, the probability of my first dice roll is a 3 out of 6, 2, 4 out of 6. And the second dice roll, same situation. Get an even on the second dice roll, 2, 4, and 6. So 3, 6 times 3, 6 is 9/36. Interesting. Interesting on that front. Maybe something's going on there. This is the reason why I wanted to make that chart, because trying to figure out all the ways you can get a 7, I mean, you might forget one. It's very, very, like, there's a lot to count in here, but I'm going to start counting them. So 1, 2, 3, 4, 5, 6. There are 6 ways to get 7.
So where the 9 come from?
The 9, so I'm doing it in my head. So that chart is looking at sums. I'm thinking about it purely in terms of like kind of listing them out. Yeah, so your first roll is either a 2, a 4, or a 6, right? And then from there, your second roll in order to be even, so like that was your first roll, and your second roll now has three options. You could either roll a 2, a 4, or a 6. Same thing with the 4. You could either roll a 2, a 4, or a 6. 2, a 4, or a 6. And those are all the different situations that would occur for you to get two evens, both rolls being even. So that's 9 total possibilities.
All those added together, 36.
Yeah, and all the different possibilities, of 36. And so then the sum is even. So I'm just going to start counting them based on my little chart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 of 36, which is kind of what we'd hope, right? It's a D6. There's the same number of even numbers as there are odd numbers, right? There's 1, 3, and 5, and there's 2, 4, and 6. So we would hope that there's an even number, like half the amount is even and half the amount is odd. But either way. Any questions on that? Okay. And then for a deck of cards. Now, you may already know these facts, especially since we live in Vegas. I would hope we all know these facts. But just in case you don't, or if you're new here and you haven't been, you'll live around the culture and you've never really experienced a deck of cards, here are some facts about it. There are 52 cards in a standard deck. No jokers. No jokers here. There are 2 colors, red and black. And there are 4 suits. There are hearts and diamonds. And then there are spades and clubs. The hearts and diamonds, like, by the way, if you already know all these facts, like if you know all the breakdowns of everything, you don't need to write it. I should have mentioned that at the beginning, but if you don't know it, these are the reds and these are the blacks. The spades and the clubs are the black cards, the hearts and the diamonds are the red cards. The 2 colors, 4 suits, and 13 cards in each suit. That's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Right? Ace does not count as a 1. So we don't consider ace to be a 1. And so if we're asking for all the odd numbers, we're thinking 3, 5, 7, and 9. And even numbers, jack can be considered an 11 in certain games, but for all intents and purposes, if we're asking for an even card, we mean just the numbered ones, not any of the face cards, which, by the way, these are called the face cards. So that's the breakdown of a standard card deck. And now that we know all those things, now you can think about how, so this is how counting cards kind of works. So, ever wondered, I mean, granted, actually counting cards is a very, very niche situation of using probability to figure things out. My previous class asked if you could get arrested for counting cards. The answer is no. It'd be really, really hard for them to prove that you were actually counting cards. But what ends up happening is if people start to try and count cards at casinos, they just kick you out and they ban you.
You count cards?
Yes. So counting cards is a process of trying to manipulate the odds to work in your favor in blackjack. So if you've ever seen 21, that's what they're doing. They also do it in The Hangover, that movie. What's his name? Zach Galifianakis' character. Is that? It's been a while, but way back when there's that scene where he's doing all the calculations in his head, whatever. But anyways, I'm getting sidetracked. So let's do an example. A single card is drawn. Find the probability of a red even. Part B will be the probability of a heart face card. And part C will be the probability of a black card. And we'll just compute them right here. Single card is drawn. Find the probability of drawing a red even. So there's two red suits. There's hearts and there's diamonds. And so looking at those in terms of evens, there's a 2, 4, 6, 8, and 10. So there's 5 even cards in each suit. And since there's 2 red suits, that means that there's 5 times 2. So that's 10 out of 52. Five from the hearts, 5 from the diamonds. Yeah. 5 from the hearts, 5 from the diamonds, adding up to a total of 10 out of the 52 total possibilities. A heart face card. So we're restricted to the hearts, and there's only 3 face cards in any suit. Since this is a particular suit, that means that there's only 3 of them, so it's a 3 out of 52 chance. And then a black card. So that would mean you could either draw a spade or a club. There's 13 spades and 13 clubs. That means that there's a total of 26 black cards. 26 out of the 52 options. I think we should just in the future for 120, we should just skip the section on bars and graphs and stuff and just add in this section on learning how to count cards. It'd be pretty fun. Just start messing with the casinos. Fun. In fact, I might do it. Why not? It's completely legal to teach how to count cards. Isn't it? Right? It would be very, very silly for that to happen. But either way. Let's see here. Do that. Skip that. Well, we're on track. So we got to do that. Okay. So I want to do a little bit of an and versus or, quote unquote. The and versus the or talk. By the way, are there any questions on the card drawing? All right. So in certain circumstances, you'll see them ask for this and this, or this or this. And I just want to make it clear, in probability, there are two types of ors in the real world. There is an inclusive or and there is an exclusive or. And in probability, we use the inclusive or. So an and means that both events occur. Both events must occur. Whereas in probability, we use an exclusive or. One or the other occurs, or both. At least one. Let me write that better. I'm sorry. At least one event occurs. If not, so there, an exclusive or is one where it's one or the other, not both. So, for example, when you're at a restaurant and they ask you to get super salad, that is an exclusive or. That is saying this one or this one. You can't pick both. Whereas an inclusive or is something like when you're asked for coffee, if they want you to get cream or sugar, right? Because you can ask for just cream or just sugar like a maniac, or you can ask for cream and sugar. Or you can be one of those purists, drinks coffee just straight. I don't get that. I'm not strong enough. Maybe one day.
Coffee in general is too bitter.
I get you.
I've had a just in coffee, just be too hydrated.
I put a little sweet there. I don't know why, but that's the only way.
Well, because it's get rid of the bitter.
Yeah.
The caffeine doesn't do anything for me anymore. I as I said, I was a Starbucks barista at one point. Yeah, we have facts about that. And like it got to the point where like I just it didn't work. I would take 4 shots, nothing happens.
4.
Yeah, like I had to do an opening shift, and so I just 4 shots, 2 pumps of white mocha sauce to make it not taste awful. Down the hatch, didn't feel a thing. But it was free. That's cool. When you're on your shift, you give you free coffee. So, and then oops, piece of food dropped. I guess I can't serve that to anybody. Kidding, I never did that. Anyways, example. Find the probabilities when rolling a d20. So a 20-sided die. What are the probabilities? Probability A is going to be the probability of rolling an even and less than 10. What is the probability of rolling your d20 and getting an even number that is also less than 10? I did this deliberately to make sure we know about the terminology. If I say less than 10, I mean strictly less than 10. So 10 is not included. If I said 10 or less than or equal to 10, that is saying that 10 is included. So granted, if that ends up happening on you and you make that mistake of including 10, let me know. And that's one, like, so your answer will be off by 1 number in the numerator. You'll be like, it should be 8 and you got 9. Let me know and I can give some partial credit back on that situation. So even and less than 10. Well, let's look at it. So 2, 4, 6, and 8, right? Those are the options. Those are the only even numbers that are less than 10. So that's 4 possible outcomes where you get a success over 20 possible outcomes. That's a 4 out of 20 situation. How about the probability of an even or less than 10? So we can list all the evens and all the less than tens and then pick them out. So for this one, we have the evens. So 2, 4, 6, and 8. Those are all the even numbers that are less than 10. And you have 10, 12, 14, 16, 18, and 20. And then you also have so that's all the even numbers. And some of them are also less than 10. So you have some of them that are both even and less than 10. And then you have the numbers that are less than 10. We've already counted for 2, 4, 6, and 8. So we just need to list the odd numbers in that category. 1, 2, 3, 4. What am I doing? 1, 3, 5, 7, and 9. You could also just list out 1, 2, 3, 4, 5, 6, 7, 8, 9, and then do 10, 12, 14, 16, 18, 20. However you want to do it, that's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is going to be 15 out of the 20 possibilities. So we were able to calculate this OR without a formula. However, there is a formula for the OR if you want to. Formula for OR probabilities. So you don't have to have this memorized. And you don't even have to use it if you don't want to. But if you do, there is a way to calculate probabilities without having to do it. Because this was kind of tricky, at least in my opinion, because I had to think back through, like I had to look at all these different circumstances. So you can also find probability of an OR event. So if you have a P of an event A or B, that's equal to the probability of A occurring plus the probability of B occurring minus the probability of A and B occurring at the same time. So I want to use this previous example to show it. All right, so as an example, let's go back to the even or less than 10. Why is the formula like that? I'd like to do this example to highlight what's going on, and then we'll explain why the formula is the way it is. So the probability of an even or less than 10 is equal to the probability of an even plus the probability of a less than 10 minus the probability of even and less than 10. And we should get the same number. We should get 15/20. If we don't, something's wrong. But the probability of an even number, there are, like, it's an, there's 2, 4, 8, sorry, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's 10 of the 20 numbers. So this is 10 over 20. And then the numbers that are less than 10. So rolling a number less than 10, that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's a 9 out of 20 opportunity. Minus, we just found this in the first part, part A. It's a 4 out of 20 chance, but you can also just do it right now. Even and less than 10, that's 2, 4, 6, and 8. So minus 4/20. And lo and behold, you get 15/20. You get the exact same number. So no matter how you calculate, you get 15/20. The reason why the formula works in the way it does, the reason why it's P of A plus P of B minus P of A and B. Notice these events might have overlap. There might be overlap in them. And there is. They're like in the numbers less than 10, there is 2, 4, 6, and 8. Those are numbers that are less than 10, and those are also even numbers. So I'm double counting them by calculating the probability of A and the probability of this thing. I'm double counting them, so I have to subtract off one set of it to get it back to being only counting it once. That's what's going on there. The only reason why I mention this is that sometimes it's easier to calculate two isolated events that, and then look for the commonalities than trying to figure out all the different possibilities going on. All right. Another example, and then we'll talk about odds. A gumball machine has 35 red, 25 white, which were always the worst tasting gumballs. Like, even though they all taste, they're all the same flavor, for whatever reason, the white ones just never tasted very good to me. It's always about the red or the blue. Red or the blue. So 35 red, 25 white, 16 blue, and 14 yellow gumballs. If you get one gumball at random, find the probability part A is going to be the probability of getting a red. Part B is going to be the probability of a white or yellow. And probably C is the probability of a red and blue. This is an example where we need to figure out, so probability is the number of, oh, I'll let you write this down. I'm getting ahead of myself. Such BS. It's already, the sun's already setting. Sun is already setting.
Daylight savings, yeah.
It is.
It is 100%. I want it done. I want it off.
I heard there's, I don't know if I heard this right or not, I'm just curious if you're over gonna get rid of daylight savings time.
They so it did pass, I believe, the House. I can't remember if it was the House or the Senate, but that bill did get passed by one of them, and then it got tied up in the other. Probably them trying to figure out, well, which one do we keep? Do we stay on daylight savings time or non-daylight savings time? My argument, just cut it down the middle. Just,
What is that?
I was realizing we decide when the day starts. We just say that like 12 a.m. happens then. Why not? We can make it whatever we want. But man,
It's like,
and I believe the sun is going to set before 5 today.
not
So I'd much rather prefer more nighttime or afternoon light. But either way. Anyways, so for this one, probability is the number of successes divided by the total number of outcomes. We need to figure out the number of outcomes because we're not given that. The total number of outcomes are 35 plus 25 plus 16 plus 14. Yes, there's only 4 different options, but the amount of each gumball is changing on that. There's not a 1 in 4 chance of getting a red because there's a lot more red than there are yellow. So we're going to look at each gumball separately. So you pick one of the total number of gumballs, which is 90. There are 90 gumballs in this thing. You can get red number 1, red number 2, red number 3, and so on and so forth. So there's 90 total outcomes. So for part A, the probability of a red, well, that's going to be 35 over 90 because there are 35 red gumballs in there. You can get any one of those 35 and satisfy this probability. B, the probability of a white or yellow, which you can also do B, P of W or W or a Y, however you want to do it. And so there is no overlap between these two, but so you can use the formula, but you don't need to. So there's 25 white and 14 yellow. So we're just going to add those two numbers up. 25 plus 14 over 90. That's 39 out of 90. And last but not least, C, probability of a red and blue. What's the probability of you getting a red and blue gumball? Goose egg. 0. So if you said or, but this is saying you were getting a gumball that is both blue and red, which there are none. They're all monocolor. They're all monocolor gumballs. So the probability is exactly 0.
That question would trick this.
Yeah. So that's why I want to talk about. If it says or, then they're talking about one or the other. Alrighty then. So now, with the remaining time, we're probably going to get I just want to keep our classes at the same spot. So we might get done early and might not. I'm not sure. The last thing to talk about, unless there's any questions on this, are odds. Odds. Because if you've ever gone to one of the casinos into the sport betting area, they never tell you a probability. They just tell you the odds. And what does that mean? So there's two different types of odds. And they're very, very closely linked. There are the odds in favor. And we'll start off with those ones. The odds in favor are a ratio, but in particular, it's a ratio of the chances of successes to the chances of failure. Not successes, chances of success to the chances of failure. That's what they mean when you hear and typically they say the odds of this happening. So they're talking about the odds in favor. Most of the time we talk about the odds in favor. However, every once in a while they say the odds against. So be careful on the verbiage. So as an example of this, determine odds in favor of drawing a spade from a standard deck of cards. Determine the odds in favor of getting it. So, chances of success. How many different ways, how many possible ways can we succeed at doing this? You could draw you draw an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. So, number of successes is 13. You draw any one of the 13 cards in the spade suit. What about the number of failures? How many failures are there? 39, exactly right. And why is it 39? Because you have 52 total outcomes, and you're taking like every other situation besides those 13 places where you win, you lose. So we take the total number of outcomes, subtract off total the outcomes in which you win, and you'll get your outcomes where you lose. So the odds in favor are 13 to 39. "13 ways for them to win, 39 ways for them to lose." That is the odds in favor. The odds against are very, very similar. The odds against are also a ratio, but they are the chances of failure to the chances of success. So it's literally just the same thing, just flipped. Odds in favor, it's wins to losses. Odds against, losses to wins. That's the only difference. It's how you read it. Why we have two of them, I don't know. I really don't. Like, why do we need two of them? Because to confuse people in the betting office. But odds against is the chances of failures to the chances of successes. So, for example, based on our work above, the odds against drawing a spade are 39 to 13. Because as we saw above, there are 39 ways for you to lose, 13 ways to succeed. So 39 to 13. The odds against drawing a spade are 39 to 13. Any questions on that? Hmm?
It's just
That's literally all it is. It's just how you read it. My best guess is either A, it's used to confuse people at the box office when they're betting, or B, it's to confuse Math 120 students.
to
Just saying.
confuse people with like,
Yeah. Or just to confuse you guys to make us have tricky questions. One of the two. Or maybe both. Who knows? All right, that's all I wanted to get through for today. We'll pick up next time, just because I want to keep my two classes on track. So, just as a final reminder, so final quiz is in class. You need to be in class for it on Wednesday of finals week. It's just like any other quiz, though. The only difference is that it's cumulative. It's the same number of points, same time limit, all that jazz. All right, guys. If you have any questions, feel free to email me. Otherwise, I hope you guys have a lovely rest of your day, and I will see you guys on Wednesday.